All right. Section 2.3 is lines and linear equations. First, let me just remind you of some terminology from the Cartesian coordinate system. This is actually in section 2.1. The terminology is, if you need to go back and look at it, but I've summarized all the terms that you need to know on this little picture. Rene Descartes was the Greek mathematician slash philosopher who said we already have a way of measuring things in one-dimensional space. We have a ruler. We can say this is 5 inches from the wall, one-dimensional space. We've got it covered. But what about two-dimensional space? What about when we need to not only talk about width, but talk about length as well, and then locate a point in two-dimensional space? Well, he was the guy that said, let's take the horizontal number line that we already have and cross it with a vertical number line, and we'll call those two number lines axes. The horizontal number line we'll call the x-axis, and the vertical number line we'll call the y-axis, and that will be all we need to locate points in two-dimensional space. For example, if I wanted to tell you where Ben was sitting, I couldn't just say Ben's in the second desk because there are a bunch of people in the second desk here. But if I said Ben is in the second desk of the 1, 2, 3, 4, 5th row, second desk of 5th row locates that desk exactly. So it takes two numbers to locate a point in two-dimensional space. Those two numbers form what's called an ordered pair, and it's pair because it has to be two numbers, and ordered because they're always in the order the x-coordinate is before the y-coordinate. The first point's called the x-coordinate, the second number's called the y-coordinate, and they're always in that number. The point where the two axes cross is called the origin, and the ordered pair that names the origin is 0, 0. So to the right of 0, to the right of the origin, all of your x's would be positive. To the left of the origin, all of your x's would be negative. And above the x-axis, all of your y's would be positive. Below the x-axis, all of your y's would be negative. Now, one other term, the two axes divide the plane up into 4 sections. Those sections are called quadrants, and they're numbered starting in the top right quadrant. The reason that this is called quadrant 1 is that it's the section where all the x's and all the y's are positive. All the ordered pairs in the first quadrant have both a positive x and a positive y because you've gone to the right and above the origin. And then from there, the quadrants are numbered counterclockwise, quadrant 2, quadrant 3, and quadrant 4. Be careful when I ask you to name a point that you give me the x-coordinate before the y-coordinate. If I ask you, let's say this point, what's the ordered pair that names that point? That's on the y-axis. X is 0 because you haven't gone to the left or to the right of the origin. Y is positive 3 because you've gone up 3 units. So that's the ordered pair 0, 3. And what about, let's say that point? What is the ordered pair that names that point? Negative 4, 0. Negative 4 because it's to the left of the origin. The Y is 0 because you haven't gone up or down. Now, I'm hoping that you're totally fluent in the language of the Cartesian coordinate system, but if you need to read through everything I've just said, again, it's the first couple pages in section 2.1. All right, so let's move on to the concept of slope. Slope in algebra is the same thing as slope to a mountain climber. It's how much you go up or down for each unit of forward progress that you make. The steeper the slope, the steeper the mountain, the steeper the line. Slope is defined to be the rise over the run. That's how much you go up or down per unit of forward progress. That's the run. So if I give you two ordered pairs, let's say some first point, x1, y1, and some second point, x2, y2. Notice that those are subscripts, not exponents. This is just the name of the coordinates in my first point. This is the name of my coordinates in the second point. The slope formula to find the rise, to find out how much you've gone up from this point to get to this point, you just subtract the y's. And to find the run, you just subtract the x's. So the slope formula is y2 minus y1 over x2 minus x1. You need to know that formula. And also you need to know what the slope tells you about the line. If you have a line that's going uphill from left to right and you take 2 points and use the slope formula, that better come out to be a positive slope because a line going uphill from left to right has positive slope. A line going downhill from left to right has negative slope. If I give you the equation of a line, which we haven't even talked about yet, but if I give you the equation of the line and you look at it and say, oh, the slope is -2, then when you graph that line, it better be going downhill from left to right because that's what negative slope means. Horizontal lines and vertical lines are special cases, and I want you to get them straight. Let's do these 3 examples right here, and using the slope formula, find the slope of the line containing the points that were given in these 3 examples, and see if we can figure out what the slope of a horizontal line and the slope of a vertical line are. Hopefully you remember, but if you don't remember, we're going to figure it out. Page 178. Number 18. Those are our 2 ordered pairs, -1, 1, and 2, 3. If you need to, you can label those coordinates x1 and y1, x2 and y2. And then just substitute them into the slope formula. By the way, the best way to make sure that you have all the formulas that you need in your head on test day is on every problem, write down the words for what that formula gives you and then write down the formula. What happens in your brain is those words become associated with that formula so that when on the test you encounter some problems that say find the slope, the word slope triggers the formula in your head and you have what you need. So write down the name of the formula and the formula if you want to make sure that you get those memorized and have what you need on test day. This is the slope formula. And it's what I use to find the slope of a line. If I'm given 2 points. Using the points that I'm given, that would be y2 minus y1 would be 3 minus 1. x2 minus x1 would be 2 minus -1. And that simplifies to 2/3. If I graph that line, would I expect it to be going uphill from left to right or downhill left to right? Definitely uphill from left to right. And what if I wrote those ordered pairs in the reverse order? What if I had given you the point 2, 3 and then the point -1, 1? What if you substituted the x and y's in the reverse order in that slope formula? You think it would make a difference? Well, let's see. What if I had said 1 minus 3? What would that be? -2. And what about -1 minus 2? -3. But what is -2 over -3? a positive 2/3. So the slope would be the same no matter which ordered pair I wrote first. The slope of the line would be the same. The only thing that will cause you to miss this is if you subtract your x's in one direction, but then subtract your y's in a different direction. Then you'll miss the slope. No matter which 2 points on that line, how many points are there on this line that connects these 2 points? Infinitely many. There are infinitely many points on that line. If I knew 2 other points on that line and used them to find the slope, I would come up with the same thing. Maybe if I picked 2 points that were farther apart and used the slope formula, I would get maybe 8/12, but 8/12 still reduces to 2/3. The slope of a line is the same throughout the line. That's why it is a line. All right. That's so easy that you wouldn't need 2 more examples except for something interesting happens on 20 and 22. Let me write down the ordered pairs in case you don't have your book with you. But you find the slope of the line, number 20, between the point 4,2 and -5,2. And then number 22, 2,0 and 2,2. On number 20, when you use the slope formula, what do you get in the numerator? 0, and in the denominator, -9. I'm going to be totally upfront with you right now. If you leave 0 over -9 as your answer on the test, I'm going to count it wrong, not even partial credit, because you're in college algebra. You need to tell me what 0 over -9 is. What is it? 0. And remember, we talked about this the first day of class. If you're sitting there on the test going, ooh, which one's 0 and which one's undefined, just check your answer. Does 0 times -9 give you 0? Yeah, it does. So this line has 0 slope. Now, what if you were on a road and you saw a traffic sign that says road ahead has 0 slope? What would that mean about the road? It's just flat. All right. It has 0 slope. It's just flat. It is horizontal. As a matter of fact, we weren't asked to graph this line, but if we were, think of what it would look like. X is 4, Y is 2, and when X is -5, Y is 2. And if you connect those 2 ordered pairs, sure enough, it's a horizontal line. Play like it's horizontal. My tiny bit of error is magnified there because I have this zoomed in. It looks horizontal on my paper. It doesn't look horizontal up there. But it's a horizontal line. And if you have any trouble keeping the words horizontal and vertical straight in your head, just think of the horizon when you look off in the distance. It's this way. If you ever see the horizon going this way, be afraid. I'm not sure what that would mean, but this is the horizon. And the word vertical, those blinds are called vertical blinds. They go up and down. So Horizontal is like the horizon, and vertical is like vertical blinds. Excuse me. One other thing that I wasn't asked for in this problem, because I know what's coming up in just a minute, I'm going to go ahead and mention it. What's the same in those two ordered pairs? They have the same y value. And since the y's are in the numerator of the slope formula, when you subtract something from itself, you're always going to get 0 in the numerator. And 0 in the numerator is always going to give you 0. As a matter of fact, the equation of that line, the other thing I wasn't asked for, but I know is coming up in a minute anyway, the equation of that line is the line where all the y's equal 2. Here's the point 0, 2, 1, 2, 2, 2, 3, 2. There are infinitely many points on that line, but in all of those points, the y is 2. So if I ask you for the equation of that line, you could just look at those 2 points and say that's the line y equals 2. As a matter of fact, I've got a corny acronym to help you with everything you need to know about horizontal and vertical lines. Everything you need to know about horizontal lines is summed up by the corny acronym HOI. HOI stands for whenever y is a constant, you always get a horizontal line, and a horizontal line always has 0 slope. That's all you need to know about horizontal lines. The equation is y equals something, in this case y equals 2. It's always horizontal, and the slope is always 0. When you use the slope formula on number 22, what did you get in the numerator? 2 minus 0 is 2, and what did you get in the denominator? 0, and if you leave me 2 over 0 for the slope on the test, I'm counting it wrong. No partial credit, because you need to know that 2 over 0 is what? Undefined. Neither one of those fractions equaled the word no, did it? There is no fraction that equals the word no. A fraction can be 0, it can be undefined, but it can't be no. Therefore, I want to go to all the 8th, 9th, 10th grade math teachers who are using the term no slope and say there's no such thing. There's no such thing as no slope. Slope is either 0, or it's undefined, or it's some positive number, or it's some negative number. Don't use the term no slope, because that's coming from a fraction. And the fraction either equals 0 or it's undefined. It's not going to equal no. All right. Let's see. If I ask you to graph the line containing those 2 points, you wouldn't have to know anything funky was fixing to happen. You could just plot the point 2, 0 and the point 2, 2, 2. And as soon as you did, you'd go, oh, that's just a vertical line. How could I have told that that was going to be a vertical line by looking at the 2 ordered pairs? The x's are the same in both ordered pairs. Whenever the x's are the same, when you subtract the x's in the slope formula, you're going to get 0 in the denominator. And 0 in the denominator is always undefined. So the corny acronym that will help you remember everything you need to know about vertical lines is VUX, V-U-X, which stands for whenever you have x equals a constant, which for this problem, the equation of the line would be what? X equals 2. x equals a constant always gives you a vertical line. And a vertical line has undefined slope. There aren't a lot of things that we have to memorize in college algebra, but the ones that you do have to memorize, as soon as you give me blank paper on a test, I'm going to write those formulas down at the top of the test because I don't want to get to word problems and completely freak out and forget all of my formulas and miss other problems on the test just because I forgot my formulas. If I were you, I'd write Hoy and Vux at the top of my paper and then use it. If you don't have horizontal and vertical lines straight in your head, it's going to be just about an automatic minus 15 on the test. If I say graph y equals 2 and you put a vertical line, there's no partial credit I can give on that. That'll be minus 5. Or if I say, what is the slope of that line? And you put 2 over 0, there's no partial credit I'm going to give on that. That'll be minus 5. So don't miss what's supposed to be the easy things on the test just because you don't have your stuff about horizontal and vertical lines straight in your head. All right. Let's see. That was Roman numeral 2 on the handout. 1 was all the terminology. 2 is what you need to know about slope. 3 is different methods for graphing linear equations. And they're graphing linear equations so early in school now. I'm not sure what grade it's gotten down to, but they start talking about functions and making x, y tables. I'll give you an x, you substitute it in, find the y, or I'll give you a y, substitute it in, and find the x. They're doing that. Does anybody know? Does anybody have a third grader? Have you seen it yet in third grade? Yeah, it's happening. Mm-hmm. Yeah. Yeah. It's amazing how far this has been bumped down, which is why y'all should not be having trouble with it. The first way that you learn to graph a linear equation is by making a table. Just choose any two x value or any three x values, substitute them into the equation and find the y values. Now, how many points does it actually take to graph a straight line? It only takes 2. You give me any 2 points in the whole wide world, I can put a straight line through them. I only said 3x values because that third one serves as a checkpoint. If it's not in line with the other 2, then I know something's wrong. I don't know which one's wrong. I'll have to go back and check all 3, but the third one serves as a test point. You could also choose y values and find the x's. That doesn't matter at all. Let's see, number 72 on page 179. Y equals negative 3x plus 4. When I first saw that in 4th or 5th grade, I'm not sure when I learned about negative numbers, but if you ask me to graph that, the first way I learned to graph was by making a table. Eeny, meeny, miny, mo, what are the 3 most boring x's in the world? Yeah, that works. 1, 2, 3, or negative 1, 0, and 1. It doesn't matter what you choose x to be because the line's going forever to the left and forever to the right, unless it's vertical, and that's a whole special case. So you can pick any x and any y, or excuse me, any 2 x's or any 3 x's, find the y's that go with them, and use those 3 points to graph your line. I'm rather boring. I'm going to stick with my negative 1, 0, and 1. There's nothing magic about that. When you let x be negative 1, you're going to have negative 3 times negative 1 plus 4, and that's 7. So the ordered pair negative 1, 7 is one of the points on your graph. When you let x be 0, y is going to be negative 3 times 0 plus 4, and that's 4. The point 0, 4 should be on your graph. And when you let x be 1, y is negative 3 times 1 plus 4. So the ordered pair 1, 1 is on your graph. If you plot those 3 ordered pairs and they don't all lie on the same line, then go back and check your math right here and find your mistake. They should lie on the same line. Negative 1, 7, 0, 4, and 1, 1. Even without graphing paper, that's a decent line. If you want some graph paper, you're welcome to buy some or print some off the internet. Just print a few pages, Google graph paper, and then print a few pages off the internet. But I don't care if you use graph paper or not. Nobody's worse at art than I am. And if I make my points big enough, I can hit them. If it looks relatively like a straight line, if I can tell it's not a circle or a parabola, it's good enough. In my math lab, trying to think, y'all haven't done any graphing in my math lab, have you? Haven't done any yet. But on that orientation set of problems you did the first day, it told you how to graph a line. You just click on line to tell the calculator what you want to draw, and then click on 2 points, and my math lab will connect them for you. All right. Making a table is the first way we learn to graph a line. It's also the most inefficient way. It's the slowest way to graph a line. There are faster ways. But before we can talk about the faster ways, we have to skip down just a little bit on my outline to this slope-intercept form. I didn't tell you that y equals negative 3x plus 4 was in any special form. I just said make a table. But it turns out that when the y is by itself, it is a special form. It's slope-intercept form. Whenever the y is by itself, that's slope-intercept form, and it's useful because if you have an equation in slope-intercept form, you can automatically see 2 very important characteristics of that graph. The coefficient of x, whatever it is your slope, and that constant on the end, whatever that is your y-intercept. So if I give you an equation in that form, like my number 72 was, look how much faster we could have graphed that. The y is by itself, so I can just look at it and see that the slope is what? Negative 3. Did you say something else? Did you say? Okay, the slope is the coefficient of x. And the constant on the end, that's your y-intercept. You wouldn't even have to write that down. If I gave you y equals negative 3x plus 4, and you thought, hey, the y-intercept is 4, then just put a dot on the y-axis at 4. And then the slope being -3. I'm used to slope being a fraction. How could I write that -3 as a fraction? Yeah, put it -3/1. And remember that slope is defined to be the rise over the run. So in this case, the rise is -3 and the run is 1. What do you think we should do with a negative rise? Yeah, go down. Start at this y-intercept we plotted and go down 3 and then run 1. That's run +1. So I assume I'm supposed to go to the right. If I accidentally went down and to the left, would my line have negative slope? It would be going uphill from left to right. And I know a line with negative slope is supposed to be going downhill from left to right. So when your slope is negative, count the rise down, but the run is still positive. Or isn't -3/1 the same thing as +3 over -1? I could start here and go up 3 to the left 1, and I'd get another point on the same line. So you can go down and to the right or up and to the left. Just don't go down and to the left or your line won't have a negative slope. That's much faster than making a table. You give me any line that's in, or any equation that's in slope-intercept form, I'm going to use the slope and the y-intercept to graph it. I never make tables. What about, let's see, what's number 35? Oh, number 35 in the book doesn't give you the equation of a line. It just gives you graph the line with the slope -2 that goes through the point -2, -3. So you're not given the equation, you're just given some information about that line. You can still start by plotting that point at -2, -3. And starting at that point, how would I use the slope? What does slope -2 mean? Down 2 to the right 1 to get a negative slope. Start at the point that you're given, go down 2 to the right 1, and here's that line. There's another form that the equation of a line can be in. It can be in general form. General form is when the x and y are on one side of the equation and the constants on the other. If you give me an equation in that form and I wanted to know the slope, what would I have to do? Yeah, solve for y to get it in slope-intercept form, and then I can use the slope and the y-intercept to graph it. So any linear equation, you can either get it in general form or slope-intercept form, except for horizontal and vertical lines. They're just an entirely different situation. But if you give me general form, I could solve for y and then use this method, but there's actually a faster method when your equation's given to you in this form. When you're given the slope and the y-intercept, I would use the slope and the y-intercept to graph the line. But if let me write a note right here. When the equation is in, oh, I typed it right there. I've had that thought before. When your equation's in general form, then it's easiest to find the intercepts. Think about why that is. The intercepts, or every diagonal line, has both an x-intercept and a y-intercept. The x-intercept is where the graph crosses the x-axis. And what is true about any point that's sitting on the x-axis? The y is 0. You have to be just a little bit more specific and say the y is 0. The x could be anything, depending on whether I'm at the origin, to the right of the origin, to the left of the origin. The x can be anything, but the y is always going to be 0. And what about the y-intercept? That's the point where the graph crosses the y-axis. What's true of any point sitting on the y-axis? Its x is 0. So if you have an equation that's in general form, you can let y be 0 to find the x-intercept and find, or let x be 0 to find the y-intercept. And I'll do an example to show you why that's so easy when your equation's in general form. For example, number 78. On the test, I don't care what graphing method you use. If you want to make a table for every line you graph, that's fine. It'll take you longer and you may not finish the test, but you'll get the problems you get done correct. If the y is by itself, the faster way to graph is by using the slope and the y-intercept. But if the equation is in general form, and that's the first thing I think when I see that equation that has the x and y on one side and the constant on the other, the fastest way to graph that function is just find two ordered pairs by letting the x be 0 in one and letting the y be 0 in the other. In general form, that's super easy because if you let x be 0, you can just cover up that x term. 0 times anything is 0. So just cover that up and you could see what y would have to be for that equation to be true. What's the y-intercept? Yeah, divide both sides by 3 and you find the y-intercept is 2. When you let y be 0, what is 3 times 0? 0, so just cover up that term. You have negative x equals 6, so what's the x-intercept? Negative 6. And that's all you need to graph the line. Zero 2 is on the y-axis. Negative 6, 0 is on the x-axis. Some folks don't like having 3 different ways to graph. They want to do them all the same. If you wanted to graph all of these the same, I wouldn't make a table. I would solve them all for y. But I would like for you to get to the point where you could look at it and say, this equation is in slope-intercept form, so let me use slope and y-intercept. But this one's in general form, so let x be 0, then let y be 0. That's the fastest way. What about number 80? Number 80, we have 3x plus 2y equals 6. The first thing I want to pop in your head when you see that x and y on one side and constant on the other is, hey, that's general form. And so the fastest way to graph it would be to find the what? And what are you finding when you do that? The intercepts. When you let y be, sometimes it's hard for me to beam you the word that I'm wanting you to say back, but when you let y be 0, you're finding the x-intercept. When you let x be 0, you're finding the y-intercepts. But see, I'm trying to get these words in your head so that when you see that, you first think, hey, that's general form. And the second thing you think is, I'm going to find the intercepts. When you're taking the test, you don't have to write those words down. It is very helpful to think those words. And then put down parentheses for two ordered pairs. Let x be 0 in one and y be 0 in the other. When you let x be 0, what is this first term? 0, so just cover it up. You have 2y equals 6, so y has to be 3. That's your y-intercept. When your y is 0, cover up that second term. If 3x is 6, then what does x have to be? 2. That's your x-intercept. And that's all you need to graph that line. Actually, if you gave me that problem on the test and said, graph that line, I wouldn't write any of that down. I'd cover up the x and say the y-intercept is 3. I'd cover up the y and say the x-intercept is 2. And then I'd connect those 2 points. I have a 1,000-point bonus question for you. If you get it right, you don't have to come back. Why is that line going downhill from left to right if the coefficient of x is positive 3? No. You don't have to come back. Aren't you excited? If you solve for y, if you got the y by itself, the coefficient of x would be negative. You'd have to subtract the 3x and then divide by 2. The slope of that line is actually negative 3/2. So if I started here at the y-intercept and went down 3 over 2, I would have the same line, but that would be the slower way to graph it. You cannot say the slope is the coefficient of x unless you have it in slope-intercept form, unless you have the y by itself. All right, why do I have one more of those? That doesn't seem particularly exciting. Oh, I see. First thing I think is that's general form. So find the intercepts. Let x be 0, then let y be 0. When you let x be 0, what do you get for the y-intercept? 0. When you let y be 0, what do you get for the x-intercept? Is that enough information to graph a line? Really, that's the same point, and you can't graph a line with only one point. If I said graph the line through the point 0, 0, well, there are infinitely many points that go through that line. I still don't know if it has positive slope or negative slope or how steep it is. I have to have more than one point to graph the line. So what can I do? You could get it in slope-intercept form. That's the only time I get general form into slope-intercept form is if the intercepts are both the origin and I have to have some more information. If I solve that for y, just subtract x from both sides. And what's the slope of that line? -1, which means start at my y-intercept and do what? Down 1 to the right 1, so that my line is going downhill from left to right. Or you could have found another ordered pair by just letting x be something else. If you let x be -2, what would y have to be to satisfy that equation? +2, because -2 plus 2 is 0. That means the point -2, +2 is on that graph. It's about right there. So you get the same line no matter what method you use. All right, let's see where we are on the outline. We've talked about making a table, but I never graph lines by making a table. I either say, hey, this is in slope-intercept form and use the slope and y-intercept, or I say, hey, this is in general form. Let's just let x be 0 to get the y-intercept and y be 0 to find the x-intercept. The only time I don't use one of these two methods is when I have a horizontal or vertical line. If your equation only has one variable in it, an x with no y or a y with no x, then it's not a diagonal line. It's either horizontal or vertical. Which one is, let's say, y equals 7? Would that be horizontal or vertical? Horizontal? Is that what y'all said? Okay. I only have one good ear and I have a microphone in it. Hoy and Bucks will help you out. If I say y equals 7, you look at Hoy and go, if y is a constant, then it's a horizontal line. If I say graph the line x equals -2, you look at Vux and you think if x is a constant, then you get a vertical line. So 84 and 86 in the homework. 84 is the line y equals -1. Even if you forgot Hoy and Vux completely, think about all the ordered pairs where y is -1. Well, certainly y is -1 right there. That's the point 0, -1. But I could also plot the points 1, -1, and -1, -1. And then I'd see all the points where y is -1. If the y is not changing, then this is the only thing the line can be doing, going horizontally. Whether you think of different ordered pairs where the y is -1, or you just think the corny acronym y is a constant, so it's a horizontal line, you're going to get the same graph either way. 86, you have x equals 2. Again, you can either think of the corny acronym, if x equals a constant, then I'm going to get a vertical line. Or you can just plot some points where x is 2. Here's the point 2, 0. 2, 1 is going to be above that, and 2, negative 1 is going to be below that. They form a vertical line. All right. I think I almost lost some people right about here. I saw yawning and nodding off. This is easy. I've been doing this since the 7th grade. Good. You get all these problems right on the test. What else? We've talked about our horizontal and vertical lines. We've talked about different forms that a line can be given to us in. If it's given in general form and the directions say graph, I'm going to find the intercepts. If the y is by itself, I'm going to use the slope and the y-intercept. But there's one other kind of problem we have to do in this section. You have a bunch of problems that don't say graph the line, but find the equation of the line. Usually, about 9 times out of 10, if the problem says find the equation of the line, we're going to use point slope form. And it's about the 4th thing on this sheet that you need to have memorized and make sure you jot down at the top of your paper when I give you the test. Notice that point slope form looks a whole lot like the slope formula. If I just took the slope formula and multiplied both sides by the denominator to clear out fractions, I'd have y2 minus y1 equals m times x2 minus x1. Looks a whole lot like that. So if I give you some point, you can label it x1, y1. And if I give you some slope, you can label it m, and then just substitute it into that formula. For example, 46 through 70, I'm certainly not going to do all of those, but all of 46 through 70 say find the equation of the line. And let's see, number 48, you're given 2 bits of information. The slope is 1/2 and containing the point 3, 1. Here's what I'm going to think. The directions say find the equation of the line, and I'm given what 2 things? And when you're given a point and a slope, what form should immediately pop in your head? Point slope form. That's why it's named point slope form. That's what you need to find the equation of the line. Best way to make sure these words are associated with this formula is to write down the words and the formula every time you use it. The point that I'm given is my x1, y1. The slope that I'm given is my m. And the x and y without subscripts, those are the variables that are going to end up in my equation. I don't put anything in the place of xy, just x1, y1. So my equation would be y minus y1, that's 1, equals 1/2 times x minus x1 is 3. You need to read the directions in the homework. If the directions say leave your answer in point slope form, that's good enough. That's point slope form. If the directions say write your answer in slope intercept form, what will I have to do? How do I get an equation in slope intercept form? Solve for y. You'd have to clear out the parentheses. And then add 1 to both sides. If you can do -3/2 plus 1 in your head, yay. But if you're thinking, where did she get that -1/2, then you need to use a calculator. What if the directions say get the equation in general form? What does general form look like? And your constant on the other. So if you wanted your x's on the same side, you could subtract that negative, or you could subtract 1/2 x from both sides. But that's not going to be the answer in the back of the book. I don't know if my math lab will count it right or not, because math teachers never leave an equation in general form with a fractional coefficient. How could I clear out that fractional coefficient? What could I do to both sides? Multiply by 2. I suspect that in the back of the book, they will have multiplied by -2. There's more than one way to write this answer, and there should be more than one thing that my math lab counts right. But what I bet is done to get the answer in the back of the book is to multiply both sides by -2. -2 times -1/2 x is positive x. -2 times y is -2y. And -1/2 times -2 is +1. I think that's the answer that would be in the back of the book. Now, if you had multiplied by 2 but not -2, and you put the answer -x plus 2y equals -1, that technically is correct. Math teachers don't leave a negative coefficient on the x. I think that I went into the homework and made all the directions say write your answer in slope intercept form. I'm about 80% sure that I did, because slope intercept form is just easiest to get. And that's what I know, that's what the directions on the test say. Write your answer in slope intercept form. All right. What about number 50? First thing I think on number 50 is I have 2 points. Oh no, I don't have a point-point form. But what? I don't have a point-point form, but I have a point-slope form. And if you give me 2 points, I can find the slope. So that's what I need to do. Use the slope formula Oops. To find the slope, and then I'll have the same information that I had on the previous problem. I'll have a point and a slope. The slope would be 5 minus 4 over 2 minus negative 3, or 1/5. And now that I have the slope, I can eeny, meeny, miny, mo, pick either point. Doesn't matter which one I use. I'll get the same equation of the line, because ultimately my line has to go through both of those points. That's why it doesn't matter which point you choose. I'm going to say plug that into point slope form and finish. Some of these problems I'm just going to get you started and then say dot, 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 because I want to get through all my examples. What about 52? I'm given some other information. I'm given slope equals -2 and the y-intercept is -2. If you give me the slope and the y-intercept, what form of an equation would be fastest to use? Slope-intercept form. That's why it's named slope and y, or slope-intercept form. The y-intercept is your b. The slope is your m. So what's the equation of that line? Y equals what? Yeah, -2x minus 2. I put -2 in place of the m and -2 in place of the b. Number 54, I'm given that the x-intercept is -4 and the y-intercept is +4. And I'm thinking, oh no, I don't have an intercept-intercept form. The most common mistake is to put those two numbers together as if they were one ordered pair, the ordered pair -4, 4. But that's not the case. What I'm being told is that the x-intercept is here and the y-intercept is here. I want to find the equation of that line. How would I do it? Say that one more time. I don't understand yet. Yes, you have to realize these are ordered pairs. This is the ordered pair -4, 0, and this is the ordered pair 0, 4. And once you have two ordered pairs, what can you do? Find the slope. the slope of that line is 1, and I know the y-intercept is 4, what's the equation of that line? Y equals, your m is 1. You don't actually have to write it. 1x is just x. And your y-intercept, your b, is 4. So on that one, I just had to find the slope, and then I could use slope-intercept form. The next two problems are problems that require absolutely no work, but they're some of the most missed problems on the test. 56 says, find the equation of a line with undefined slope and through the point 3, 8. I can't plug the word undefined in the place of m. I need to think about what that line looks like. If its slope is undefined, what does the line look like? It's a vertical line. So first thing I'm thinking is undefined slope gives me a vertical line. But if the directions say find the equation of the line and I write the word vertical, is that an equation of a line? No, that's not the right answer to the question. That's the answer to the question, what does the line look like? But what's the answer to the question, what is the equation of the line? Look at Vux. It's x equals something, and if it's going through the ordered pair 3, 8, what does x have to be? Yeah, the equation of the line is x equals 3. If on the test you just put the number 3, that's not an equation of a line. I don't know what you mean. I don't know if you mean the line x equals 3 or the line y equals 3 or the balance in my checkbook right now. So if you want to give the equation of the line, you have to give an equation. And what about number 57? Says the line is horizontal and through the point -3, 2. When I see the word horizontal, I think of the corny acronym HOY, and the equation of a horizontal line is y as a constant. To go through that ordered pair, the constant would have to be 2. So these are supposed to be the easiest 10 points on the test, but folks who don't know what they're supposed to know about horizontal and vertical lines lose a whole letter grade right there. All right, one other thing we need to talk about real quickly. Actually, we have 2 other things. I'm just not sure we'll get to both of them. The rest of the problems, 60 through 70, either say find an equation that's parallel to the given line or find an equation that is perpendicular to the given line. I'm going to give you a line, and if I ask you to find a parallel line, that's what parallel means, they never cross. Why do they never cross? Because they have the same slope. Boy Scouts of America, if you are climbing a mountain and you get lost, what are you supposed to do? Nobody has their Eagle Scout badge. Oh, what should you do? Think about it. If you're lost in the woods at night, you're supposed to sit down. You don't wander around lost, because if you're on the side of a mountain and you're wandering around, the search party may be wandering around a parallel path, in which case your paths are never going to cross. You're never going to get found. So parallel lines are parallel because they have the same slope. If I give you the line, let's see, if I give you the line number 60, says parallel to y equals negative 3x, and through the point negative 1, 2. Hey, is that just a horizontal line? The answer is no, but why? Because it has an x. Just y equals negative 3 would be a horizontal line, but negative 3x is not a horizontal line. What is the slope of that line? Negative 3. By the way, this is the symbol for parallel. If this line has a slope of negative 3, what's the slope of any line parallel to it? Same thing. So just use this point and this slope in point slope form. I'm going to put dot, dot, dot so we can do 2 more examples. Now, parallel lines are parallel because they have the same slope. That's why they never cross. But the other thing you need to know is that perpendicular lines have slopes which are both opposites and reciprocals. Not just opposites, not just reciprocals, has to be both. So this line that has a slope of negative 3, if this were changed to perpendicular to this line, what slope would I have to use? Positive 1/3. Make sure you take the opposite and the reciprocal. The most common mistake is to do parallel, no matter what the directions say. It says perpendicular, make sure you take the opposite and reciprocal slope. So number 68, I'm going to use this, I'll write it, perpendicular. I'll show you the symbol next. A perpendicular to x minus 2y equals negative 5, and through the point 0, 4. What's the first thing I have to think? Well, if I want a line that's perpendicular to this line, what do I have to find out about this line? The slope, and how do I find the slope of this line? But not until I've solved for y. I have to get the y by itself. So subtract x from both sides. And then divide each term by negative 2. That can be written more simply as y equals, is that slope positive or negative? A negative divided by a negative is a positive. That's positive 1/2 x plus 5/2. So the slope of this line is what? One-half. And if I ask you for a line parallel to this line, what would you use for the slope? Parallel. Same thing. You'd use 1/2. But if I say perpendicular, then what do you have to use for the slope? Negative, not negative 1/2, but -2, opposite and reciprocal. So then you could use the point slope form, y minus 4 equals -2 times x minus 0. And just finish that one real quickly. Add 4 to both sides. That's the equation in slope-intercept form. All right. I think the homework has 1 or 2 word problems. Here's the secret to linear equation word problems. You have to be given one of 2 things. Either you're given the information for 2 points, then you use the point and find the slope and use point slope form, or you're given a point and a slope and you use point slope form. That's the only 2 things that can happen with a linear equation word problem. So if you do have a couple of problems in the homework, you may need to click View Example and read through an example, but if you have trouble after that, just email me.